In this video, we're going to be looking at section 2.1, which is on graphing. A solution to an equation of two variables, x and y, is any x comma y, any pair of numbers that, when substituted into the equation, results in a true statement. So for example, 1 comma 3 might be an example of a solution. That means x is equal to 1, y is equal to 3, and when those two numbers are plugged in for x and y, we end up with a true statement. X comma y is called an ordered pair, which is literally a pair of numbers in a certain order. For x comma y, the value of x must go first, and the value of y must go second. The order is important. Solutions of equations of two variables have the form x comma y, and x comma y are also points on the xy plane. So these are two distinct concepts that happen to be linked together by the fact that both of them involve ordered pairs of numbers. Solutions to equations are ordered pairs. Points on the Cartesian coordinate system are also ordered pairs, and it's this connection that allows us to switch from one form to the other, to go from looking at solutions to the equation to looking at points on the graph, because they both have ordered pairs at their core. All right, so let's take a look at an example. Show that each pair is a solution to the equation, then graph the two pairs to determine another solution. All right, so the equation that we have here is y plus 2x equals 6. One of the pairs that we're given, one of the ordered pairs is 2 comma 2. And we want to know, is that pair a solution to this equation? So this one's kind of an unfortunate first example because the numbers are the same, so the order almost doesn't matter when the two numbers are exactly the same. But the order here tells us that the x value is equal to 2. That's the first number. And the y value is also equal to 2. That's the second number. So the order of the numbers tells us which one is x and which one is y. And then we plug those numbers in for x and y into this equation. So for y, we're going to plug in 2. For x, we will also plug in the number 2. And we want to confirm that this ordered pair is a solution to the equation. So they're kind of already telling us the answer in the directions. Show that each pair is a solution. So the answer is going to be yes. We're told in the directions these are solutions, but we want to confirm that before we answer the question. So we simplify by the order of operation. We do multiplication first. 2 times 2 is 4. 2 plus 4 is going to give us 6. And so we end up with 6 equals 6, which is a true statement. So because that's true, I can answer in the affirmative up here that yes, 2 comma 2 is a solution to this equation, because when I plug those numbers in, I end up with a statement that is true. Let's check this second ordered pair. We have 4 comma negative 2. That means that x is equal to 4 and y is equal to 2. So we'll plug those two numbers into this equation for those particular variables. So for y, got to get this in the right order. For y, we're plugging in negative 2. And for x, we are plugging in positive 4. So this is a pretty common way of plugging a number in by putting parentheses around it. I'm not doing that for the y variable though, because there's nothing else going on around the y variable. But for x, we're multiplying by 2, so I put parentheses around the number that I'm plugging in for x. And we should again confirm that 4 comma negative 2 is a solution to the equation. We should get something true here. So let's follow the order of operation again. We'll multiply. 2 times 4 is going to give me 8. I'll copy everything else down. Negative 2 plus 8 is indeed 6 again. And so we get a true statement, which again tells me that this ordered pair is a solution. All right, so 4 comma negative 2 is also a solution to the equation. So what they want us to do is to take these solutions to the equation that happen to be ordered pairs, an x value and a y value, and plot them as points on the Cartesian coordinate system. Points on the Cartesian coordinate system are also ordered pairs, an x value and a y value. So for example, we can plot the point 2, 2 by finding 2 on the x-axis, which is right here, and 2 on the y-axis, and finding the point that lines up with both of those at the same time. The location that lines up with both of those at the same time is this location here. Lines up with 2 on the x, 2 on the y. So that point is labeled 2, 2, which matches the solution over here, which is 2, 2. Right, so that's how we're able to go from equations to graphing. Right. We'll do the same thing with this one, 4, -2. So we want to line up with 4 on the x-axis because the x value is 4, -2 on the y-axis because the y value is -2. That gives me this point right here. So this is the location that lines up with 4 on the x, -2 on the y. So we get these 2 points. Now, this problem's it assumes a little bit more than maybe it should. So something you need to know about this equation, it doesn't tell us this. I don't think it says anywhere here. No, it doesn't say it in the directions. So you just have to assume, or you need to know, that this equation, when you graph it, would graph as a straight line. And so we get these 2 points, and what we want to do is connect these 2 points with a straight line. And so I'm going to do my best to draw this as a straight line. Let's see, let's see if there's a tool on here that lets me do this here. So let's see if I could do this. All right, so let me pick a different color. All right, so I'm going to try to do a straight line. Oh, perfect. Okay, this is great. So we want to graph this accurately, because if we don't draw this line perfectly straight, we're not going to be able to do the last part of this problem, which is to find another solution. So the line that we're drawing connecting these 2 points needs to be accurately drawn. When you do this on Math Excel is going to take care of that for you. It automatically will connect these 2 points with a straight line, so it shouldn't be a problem. But when you're doing it by hand, you have to be a little more careful. So I'm just going to go about that far. I think that's okay. And it also goes in this direction as well. So let me draw another straight line kind of going in this direction here. And hopefully I'll get that where it needs to go. All right, so that looks pretty close to what it should be. All right, so the way this is working, and we're going to explain this in more detail here in just a minute. But we found, or let me say it this way, we didn't actually find the solutions. They were given to us, but we were given 2 solutions to this equation, and we confirmed that they are both solutions. We plotted those 2 solutions as points on the Cartesian coordinate system, and we know from the way the equation is set up that the rest of the solutions will line up on the same straight line as the 2 solutions that we found. Right? So we find these 2 solutions, and we know that the rest of the solutions will be somewhere along the same line that's formed by the 2 solutions that we already have. All right, and so we draw a line connecting those 2 solutions together, and any other point that is along the same line will also be a solution to the same equation, right? Because of the type of equation that we're dealing with. Now, different kinds of equations will have graphs that have different patterns. So there's sometimes, for example, there's some equations where the graph will be a parabola. It'll be a U-shape. Other equations will have graphs that are V-shapes. So there's different kinds of patterns that you might get. But for this type of equation, the pattern is a straight line. So I connected the 2 points with a straight line, and any point on this straight line should be a solution to this equation. So let's confirm that. So we have this point here, for example. This point, let me switch. I need to switch back to the pen. It's trying to draw a straight line there, that's why it looked kind of funny. So we have this point here, which as an ordered pair, it's 0 on the x-axis, right? That's what it lines up with on the x. So I'll put 0 for x. And it lines up with 6 on the y-axis. So I'll put 6 for y. That point should also be a solution to this equation. So let's check, right? The x value is 6. Sorry, I said the wrong thing. The x value is 0. The y value is 6. Let's plug that into this equation and see if it also makes it true. Right, so we'll have y plus 2x is equal to 6. We're going to plug in 6 for y. We're going to plug in 2 for x. If I can get it to write it correctly, plug in 2. Sorry, I'm saying the wrong numbers again. I'm sorry. I'm kind of hungry. I think that's distracting me. So plugging in 0 for x, right, because x value is 0. And we simplify, so 2 times 0 is going to be 0. And so we're going to get 6 plus 0 equals 6, which is indeed true. Right. Let's try that one more time. So 6 plus 0 gives me 6, and so I get 6 is equal to 6, which is true. So that's another solution. And there's many more. So for example, this, we could use this point. 1 comma 4 would also be a solution to this equation. We also have this point right here, right? So this would be 5 comma negative 4. That would also be a solution. So I'll let you confirm these if you want to, but if you plug these numbers in, you will find that they also result in true statements, right? And there's many more that I'm skipping over here because, I'm just picking out the points where the numbers are easy to see, but there's a lot of other points here with decimal numbers and fractions that would also be solutions to this equation. All right. So the last part here, it says, then graph the two pairs to determine another solution. So we just needed to find one more. On Math Excel, unfortunately, it's not that open-ended. It's going to ask you to confirm a third point. But they want you to confirm the third point they give you by looking at the graph, not by actually plugging the numbers in. So confirm that a third point is a solution by noticing that point is also on the line of your graph. All right, so this is what graphing is about. So what I want to point out from that example is that equations of two variables have an infinite number of solutions, right? We could keep finding more and more, and we could have extended the line further to keep looking for more and more solutions that way as well. And you would never run out of solutions. There will be an infinite number of solutions to these equations of two variables. So there are too many solutions for us to list. Our first preference when we're trying to find solutions to equations is to give a list of what the solutions are. But for equations of two variables, there are too many for us to actually list them out. There's an infinite number of them. So our backup plan, whenever there's too many solutions to list, is to draw a picture. In other words, graphing, right? So graphing means drawing a picture of the solution set on a Cartesian coordinate system, on an XY plane. And so this is what we're going to be asked to do in this section. So when we're given an equation, instead of trying to write out all the solutions, we will draw a picture of those solutions on the Cartesian coordinate system. All right, so this is going to be our method that we're going to use for graphing in section 2.1. Now, you might think, well, I'm making things more difficult than they need to be. Why don't I just find the slope? Why don't I just find the intercepts? There are shortcuts for graphing that we're going to learn later. The problem with those shortcuts is that they only work on specific types of equations. So if you suggest we should find the slope to graph, that's a good suggestion as long as the equation is going to be a line. So that would work good on the previous problem that we just looked at, but it won't work so well on other kinds of equations because the concept doesn't really apply. Slope is a concept that really only applies to lines. So if the graph is going to end up being a parabola, then finding the slope is not really the method you should be using. And so we need different techniques for those kind of equations. And there are shortcuts for those kind of equations also. What we're going to start off learning in this section, however, is a generic method for graphing that works on any type of equation. So this method that you see on the screen right now can be applied to any kind of equation regardless of what the pattern of the graph is going to end up being. So the shortcuts of finding the slope and whatnot are very powerful methods, but they are limited to certain kinds of equations. What's powerful about this method is it has no limitations. It can be applied to any kind of equation. So to graph any kind of equation, here's what you can do. Step 1, find a handful of solutions to the equation. Now, handful is a little bit ambiguous, and I'm doing that on purpose because how many solutions you end up needing kind of depends on how well you pick the solutions and on how complex the pattern of the graph is going to be. So sometimes 3 points, 3 solutions might be enough for you to figure out what the graph looks like. Other times you might need 5 or 6, so it just kind of depends on the situation. So I would say find at least 3 or 4 solutions to your equation. That's a good starting point for getting a handful of solutions. Then you plot the solutions as points on the Cartesian coordinate system, on the XY plane. Right. What should happen after you plot those points, hopefully, is that you'll notice a pattern. So step 3 is make sure those solutions produce a pattern that you can recognize. So establish a pattern with those solutions. Assuming that you can establish a pattern, connect the points according to that pattern. If the pattern is not clear, go back to step 1, find a few more solutions, plot those as points, and then see if a pattern emerges. So or maybe you have a partial pattern, so you know the graph on one side of the Cartesian coordinate system, but it's not clear what the pattern is on the other side. Go back and find more solutions for the other side until you see what the pattern is all the way across. Right? So it never hurts to go back and find a few more solutions if you're not 100% sure what the graph is supposed to look like. Now, how do we find solutions? So in the example we just looked at, we were given solutions and we checked them out by plugging them in. How am I supposed to find my own solutions if I'm not being given what the solutions are? And the way you do that is by step 1, you pick a value for one of the variables. You know, I should probably check to make sure I don't have this typed up already. No, I don't. Okay, I didn't think I did. So you pick a value for one of the variables, and you get to pick which one. So you can pick a number for x, or you can pick a number for y. Probably 80% of the time, you're going to want to pick a value for x. It's just the equations are normally set up that way so that it's easier to plug a number in for x than it is to plug a number in for y. But there will be some equations where you're better off plugging a number in for y and going from there. Right? And so what you need to do next is once you pick a value for one of the variables, you plug it into the equation. Right? And then step 3, you solve for the other variable. So the way this works to find a solution, right? This is just step 1 of the graphing process. To find a solution is you pick a number for one variable, plug it into the equation, and let the equation tell you the value for the other variable. And that gives you 2 numbers. That gives you an ordered pair that you can then use to graph, right? So that is how you find solutions to an equation. So let's practice doing this. All right, so our equation is y equals 6 minus 4x. So we want to graph this equation. Now I know we could use the slope and the y-intercept. We are going to learn that technique later in chapter 2. But for this section, I'm going to use the generic method that we just talked about on the previous screen. So to graph this equation, I'm going to find a handful of solutions, plot them as points, and look for a pattern. So a good way of organizing those solutions is to make what's called a t-chart. And we'll have the x value in the left column, the y value in the right-hand column. To get a solution to this equation, we'll follow the steps we just talked about on the previous screen. We will pick a value for one of the variables. And I think in this case it'll be easier for us to pick a value for x. So let's pick a number for x. I will go ahead and pick 1. All right, so pick something that's not too difficult for you to work with. In theory, you could pick whatever you want. You could pick a big number, you could pick a fraction, you could pick a decimal number, but we want to keep things easy on ourselves. So I'm going to pick 1. That's usually a pretty easy number to work with. And so that's my choice. I get to pick x to be whatever number I want. I chose 1. I will plug that into the equation. So I'm plugging 1 in for x. The rest of the equation is going to stay the same. All right, so everything else just gets copied down. And then I'm going to solve for the other variable. So I'm going to solve this for y by just simplifying the right-hand side. So we'll get 4 times 1, which is 4. And then we get 6 minus 4, which is 2. So the way that worked is I picked one of the numbers. I picked the value for x. The equation tells me what the other number has to be. So essentially what's happening is the equation saying if you want x to equal 1, then you have to choose y equals 2. The equation's telling me what y has to be in order for this to become a solution based on what I chose for x, right? So if I'm picking x equals 1, the equation says then y has to equal 2 if you want this to work out. So that gives me the ordered pair 1, 2. So that's a solution. That's one solution. Let's find a handful, right? So let's find at least 4. And so if you'd like, maybe pause the video and see if you can find a solution by following the same process. Pick a different number for x, plug it into the equation, let the equation tell you what y has to equal. All right, so here are some possible choices that you could have made for x. You could have picked x equals 2. You could have picked x equals 3. You could pick 0. 0 is often a very good choice for x. And it's always a good idea to maybe choose some negative numbers for x, because sometimes equations do different things for positive numbers versus negative numbers. So maybe -1 or -2. These would have all been good choices. So hopefully you picked one of those numbers. Again, you could have picked something else. You could have picked 10. You could have picked a -15 if you wanted to. But I usually try to keep the numbers easy to work with. So this is kind of what I would have chosen, numbers like this. So let's go ahead and fill out the values for y over here. So I'm not going to write it out for every single one of these. It would take a long time to do this many, plugging in those numbers for x and writing it out on the screen. Plus, I think the software that I'm using seems to kind of get a little buggy if I do too much writing at one time. So let's do a couple of, I'll do 2, and I'm just going to override what we did earlier. So I'm going to put a 2 here, right? So we chose 2 for x in this case. I'll get 4 times 2, which is 8. 6 minus 8 is going to give me -2 for y. So if you chose 2 for x, you should have gotten -2 for y, which gives you the point 2 comma -2. If you plug in 3 for x, I'm going to just do these mentally without writing it out. If we plug 3 in for x, we will get -6 for y. Right? Because 4 times 3 will be 12. 6 minus 12 is going to be -6. If you plug in 0 for x, you would get +6 for y. If you plug in -1 for x, you'll get -4 times -1, which is +4. 4 plus 6 is going to give me 10. And if you plug in -2 for x, you would get +8, you get 14. Right? So again, I'm just working those out in my head. Not that I'm the greatest at doing arithmetic in my head, but this is something within my ability to do. If it was a little bit too much, too quick for you, take the time to write it out. Just plug each of these numbers in for x, write it out on your paper, confirm that these are the answers that you should get for y. And so this gives me a lot of points that I can graph here. So I have 3 comma -6, 0 comma +6, -1 comma 10. And I said we'll graph 4 of them, so I think I'll just go ahead and stop there. And let's plot these points. So we have 1 comma 2. Now you have to be careful graphing these, because notice these tick marks. This is a 4 here, which tells me each of these tick marks is going by 2's, right? So we have 2, 4, 6, 8, 10, 12, etc. So 1 is going to be halfway between 0 and 2, comma 2, which is the first tick mark here on the y-axis. So this would be this point here. That's 1 comma 2 right there. Then we have 2 comma -2, that's going to be right here. Maybe I should pick a different color. So right there. We have 3 comma -6, so 3 again will be halfway between 2 and 4, comma -6, which is going to be right here. We have 0 comma +6, which will be right here. And we have -1 comma 10, -1 comma 10, which will be way up here. All right, so again, -1 would be halfway between. All right, so it's starting to act buggy here. -1 is going to be halfway between 0 and -2. So notice when I plot these 5 points, the pattern that is emerging is a straight line, right? All the solutions are lining up along this straight line right here. So going through the steps again, step 1, find a handful of solutions. That's what I have right here. That's step 1. Step 2, plot them as points. That's what I've done right here. Step 3 is establish a pattern, and I think the pattern's pretty well established. It's a straight line, right? 5 points. It's really showing me pretty clearly that the pattern is a straight line. So step 4 is to connect the points according to that pattern. What we're doing here, logically speaking, is we are using what's called inductive reasoning. So inductive reasoning means you go from the specific to the general. And so I have these 5 specific solutions here, and I'm reasoning from these 5 solutions that the rest of my solutions are also going to be located along the same straight line that I'm getting with these 5. So from these 5 specific solutions, I'm making an assumption that the rest of the solutions will also line up along this same straight line. And that's what step 4 is about. Connect the points according to that pattern. So I'll start here. Oops. Let's try it again. Start here, and we will make a straight line connecting these points. And the assertion, the insinuation here, is that the rest of my solutions are going to line up somewhere along this. I'm saying the wrong thing here. Oh, I hit the wrong button. Let's go back. All right. So I'm sorry. It went a little bit off the mark there. And because I hit the wrong button, I actually can't undo what I just did. So I'm just going to have to leave it the way it is. So, and again, I was trying to do two things at once. I don't think I was, speaking the right words a moment ago. So I apologize for that. What was I saying? So the assertion we're making here is that all of my solutions will line up somewhere along this straight line. And in other words, any point that I choose along the straight line should be a solution to this equation. And any solution to this equation should show up as a point somewhere along this line. And so that's how graphing works. All right, so let's take a look at another example. All right, so here we have a fraction. So we have y equals -4. Oh, no wonder it's acting weird. I still have it on the line tool, not the pen tool. So let's try that again. Okay, -4/3 x plus 2. So again, we need to find a handful of solutions. And if you recognize, this equation's pretty similar looking to the last one. Now there is a fraction there, but the structure of the equation is pretty much the same. And so you should probably expect the same kind of graph. It's going to be a line, right? But to find where that line is located, we need some solutions. And to find solutions, we're going to have to pick some numbers for x, plug them into the equation, let the equation tell us what y is equal to. Now this time, if you follow my lead from the last example, you might think, okay, well, I'll start with x equals 1. That's what we did last time. If I plug in 1 for x, I'm going to run into a little bit of trouble. In theory, there's nothing wrong with this choice. You can choose x equals 1, and you will get a solution for y, and that does give you an ordered pair that you could graph. But notice that we're going to run into a little bit of difficulty, because 1, when I multiply it to this fraction, doesn't make the fraction go away. I'm going to end up getting a fraction here as a result, which causes problems for all sorts of reasons. One is computing with fractions is going to be a little more challenging, so I have to be careful when I'm actually crunching the numbers. But then I have to graph a point that has a fraction, which makes plotting the point more difficult to do. And on Math Excel, impossible to do, because Math Excel only lets you plot points that are nice whole numbers. So this is just not going to work for us. So in theory, yes, you could choose x equals 1. You do get an ordered pair from that, but it's not something that we're going to want to do here because the result is just too difficult to work with. All right, so I'm not going to choose 1 for x. I want to choose a number that works out nice with this fraction. So what's going to happen is whatever number I pick is going to get divided by this 3 here. So I want a number here that is divisible by 3 so that those will cancel each other out and work out nice. So 3 would be a good choice for x. So instead of choosing 1, 3 just works out better. So I'm going to plug in 3 here for x. What's going to happen is those 3's are going to cancel each other out. This 3 cancels out with this 3. And what I'm left with is -4. So I get -4 plus 2, which gives me -2. So the equation tells me if you want x to equal 3, then y has to be -2 in order to be a solution to the equation. So that's what I'm going to put here. And that gives me the ordered pair 3, -2, which I can then plot as a point, which I'll do in just a minute. What are some other good choices for x? So pause the video and think of some other good choices for x that will work out nice with this fraction here, that will make that 3 go away in the denominator. All right, so hopefully you paused the video and thought about my question. What are some other good choices for x? 6 would be a good choice because 6 is divisible by 3, so it'll work out nice if you plug in 6. 9 would be a good choice. 12 would be a good choice. Going back the other direction, -3, -6. So we'll put -6 up here. And as always, almost always, 0 would be a good choice. I'm going to squeeze 0 in somewhere right here. So any of these values would be good choices for x. That'll work out nice with that fraction that's there. So I'm going to do one more of these, but then the rest of them I'm just going to do mentally to fill in the rest of the table. So let's do -6 since it's the one I have here at the top. So I'll just write it again over here since it's kind of a mess over here, and if it's going to work out a little bit differently, so I can't just replace the number in here, and it's a little bit harder to see. So let's plug in -6 here. I'll do it over here, I guess right here. So I'll have y equals -4/3. In place of x, I'm plugging in -6 this time, and then I'll have the +2. All right. So what's going to happen, and maybe it'll be easier to see if you do it like this, think of the -6 as a fraction also. So think of it as being over 1. The 6 is going to cancel out with the 3, right? These can be reduced. So the 6 and the 3 reduce with one another. I'm dividing a 3 out of both of them, so I'll have a 1 left on the bottom. I'll have a 2 left on the top, right? 6 divided by 3 gives me 2. So now when I multiply these together, I get negative times a negative, which will be positive. And then 4 times 2 gives me 8. Over 1, right? 1 times 1 is going to be 1. So really what you get there is 8 over 1. But 8 over 1 I can just write as the whole number 8. So it works out nice. So I don't have a fraction to deal with anymore. Right? And then I'll copy down the +2. So we get 8 + 2, which is going to be 10. Right, so if we want x to be -6, then y is going to have to equal 10, which gives me the ordered pair -6, 10. If it'll let me write it. All right. Okay, sorry about that. Okay, so let's go through the rest of these values in case you might have chosen a different value for x. Here's the answers you should be getting for y. So if you want to run through these yourself and check to make sure that when you plug these numbers in for x, this is indeed what you do get for y. When you plug in 0 for x, you should get 2 for y. When you plug in 6 for x, you should get -6 for y. When you plug in 9 for x, you should get -10. When you plug in 12 for x, you should get -16 + 2, which would be -14. And when you plug in -3 for x, you should get 6, +6. All right, so let's plot some of these points over here and see what the pattern is. We have -6. Now this time, these numbers are going by ones. So -6 would be right here on the x-axis, +10 on the y-axis. So it looks like it's going to be this number, or sorry, this point right here. That lines up with -6 on the x, +10 on the y. We have +3, -2, which would be this point right here. Now it's dangerous just to stop with 2 points. Now in Math Excel, that's all you can do is plot 2 points and it automatically draws the line for you. But when you're doing this by hand, it's a little bit dangerous just to only use 2 points because 2 points always looks like a straight line. And if you made a mistake on one of these, you wouldn't be able to tell. If you do 3 points and you messed up on one of them, you'd be able to tell because the points wouldn't be lining up in the pattern that you should be getting. So you should do at least minimum 3 points, right? So let's do this one, 0, 2, right? That's this point here, 0, 2. That's going to be 0 on the x, 2 on the y-axis, and you see that third point lines right up with these 2 points here. Let's do a couple more just to drive the point home. So we'll have +6, -6, so +6 on the x, -6 on the y. I'm having trouble, I'm kind of losing track of it here. Let's see. So I think it's going to be right here. So again, lines right up with those other 3 points. And let's do -3, +6, which will be this point right here. And so you see we've done 5 points. All 5 of them are lining right up along this straight line here. And so I think the pattern's pretty clear that this graph has the pattern of being a straight line. The 5 solutions I have found so far are lining up along the straight line, so I'm going to assume that all the rest of the solutions to the equation will also line up along this same straight line. So let me switch to the straight line tool here to help me graph this a little bit more accurately. All right, and so we'll draw a straight line connecting those points. So all the solutions to the equation are somewhere along the straight line, and any point along the straight line will be a solution to that equation. Okay, I kind of missed the mark there. Let me hit the right button this time so I can do this again. All right, so this looks a little better. So Math Excel just kind of automatically draws the line for you. You plot the 2 points, it's going to automatically draw a straight line. All right, so let's take a look at another example. All right, so this one's a little more difficult. Oops, let me switch back to the pen tool. x plus 3y equals 6. So this one is our first example where the equation is not already solved for y for us. And we can leave the equation the way it is, but it's kind of difficult to know what a good choice for x would be when the equation is not solved for y. So for example, if you were to choose 1 for x, it's not going to work out very well here. I can kind of see it happening already, but in case you don't quite see it, let me show you. So if I plug in 1 for x, I'll get 1 plus 3y is equal to 6. Then I have to solve this for y, which in and of itself is going to be a little bit of a headache. And to do that, I'll have to subtract 1 to the other side to get y by itself. And then I divide by 3 and I see, this didn't work out so well, right? We get 5/3, which isn't a wrong answer. This is a solution to the equation, 1 comma 5/3. But graphing 5/3 is going to be more difficult to do. And as I mentioned already, impossible to do on Math Excel. It's not going to let you plot that point because the tool doesn't have that level of accuracy. We need solutions that are only whole numbers for Math Excel to work, but also it just makes things easier for us anyways. So even if we weren't using Math Excel, this is not the best kind of solution to be working with. We're better off having nice solutions with nice whole numbers. So that didn't work out. Now we could keep guessing different numbers for x until we finally get one that works out to be a nice answer, but there's a better way to do this. Right? So instead of picking a number for x this time and solving it for y, what I'm going to do is, like we did formulas back in chapter 1, I'm going to solve this formula for x because that looks like it's an easier task. I could solve it for y, but it looks like it's going to get messy when I go to divide by 3 to get y by itself. It's going to be easier to solve this one for x because all I have to do to solve it for x is subtract the 3y to the other side. And so I'm going to get x equals 6 minus 3y. So now that I have the equation solved for x, I'm going to find solutions, but this time what I'm going to do, instead of picking a number for x, plugging it in and solving for y, this equation is solved for x. So I'm going to pick values for y, plug it into the equation, and then let the equation tell me what x has to equal. And I can plug in whatever I want, and it should work out fine because there's no fractions here that should cause us to get bad answers, right? So I'm going to plug in 1 for y, right? So I'm plugging it in for y this time, so I'm going to plug in 1 for y, and then let the equation tell me what x is equal to. So we're going to get x equals 6 minus 3, which gives me 3. And that's what I get for x. So make sure when you set this up as an ordered pair, you put the x value first and the y value second. So ordered pairs always have to go in that order. X first, y second. It's a common mistake for students to make when you pick the value for y. A lot of students want to say, well, I picked 1 and I got the answer of 3. And so they'll put it in this order. But that is the wrong order because that's putting the y value first and the x value second. We have to put x first and y second. And so we'll put 3 as our value for x, 1 as our value for y. And that's the ordered pair that corresponds to that solution. Right, so in this situation, it's going to be easier for us to pick our values for y, plug them into the equation, and let the equation tell us what x has to equal. So pause the video, and you pick a value for y, plug it into the equation, and then see what you get for x. All right. So hopefully you paused the video and tried this out yourself. I'm going to pick a few different random values for y. Hopefully one of the ones I choose will be one of the ones that you picked. And so I'm going to choose 0 for y, and I'm running out of room. I'm sorry, I didn't plan that out very well. So let me go over here and continue over here. All right, so I'll pick 0 for y, I'll pick -1 for y, I'll pick 2 for y, I'll pick 3. These are probably the more common choices that you guys would make. So if I plug in 0 for y, if I plug in 0 here, I get 3 times 0, which is going to be 0. 6 minus 0 means this turns out to be equal to 6. So I get the ordered pair 6, 0. The rest of these I'm just going to do mentally. If you plug in -1 for y, you will get 9 for x. If you plug in 2 for y, you will get 0 for x. If you plug in 3 for y, you will get -3 for x. And so let's plot some of these points here. We have 3, 1. We have 6, 0. So 3 on the x, 1 on the y would be this point here. 6 on the x-axis, 0 on the y-axis would be this point here. 9, -1 would be this point right here. 9 on the x, -1 on the y. 0, 2, that's 0 on the x, 2 on the y-axis. And -3, 3. And you can see these 5 points that we found are all lining up in a straight line again. So again, the pattern for this graph is going to be a straight line. So let me go ahead and connect the points according to that pattern. So it's going to look something like this. And that they look a little bit off because my points aren't exactly in the right spot, but you can see they're pretty close. So I'm going to leave it at that. And the problem is when I lift the pen up off of my pad that I'm using, the line moves slightly. I can't seem to avoid that. But all right, so that is what the graph looks like. And again, the idea here is that every point on this graph that we just drew will be a solution to that equation. And every solution to that equation, if we found more solutions, should end up being a point somewhere on this line that we just drew. All right. Now, these are going to be a little bit more challenging because these equations are not linear equations. So if you were using the slope on the previous examples, or if you were using the y-intercepts and the x-intercepts to help you graph a line previously on the previous examples, you'd be okay. But this equation is not a line. This equation will have a different pattern because the equation is of a different form. So slope is not going to help us here. Intercepts, or just finding 2 points, is not going to be enough information to graph this equation. So, because the graph is not just a straight line. But we're going to use the same technique we used on the previous examples. At least, if you were following the method that I was using, we're just going to do the same thing here. We're going to use the generic method for graphing, find a handful of solutions, plot them as points, see what the pattern is, and we'll see this time the pattern is not going to be a line. It's going to be something different. So this one is already solved for y, so it'll be easier here if I pick numbers for x, plug them into the equation, and then let the equation tell me what y is equal to. So I'll start with the same one I like to choose every time. I'll pick x equals 1. We'll plug that into the equation for x. And then we'll simplify to find out what y is equal to. So we'll get 1 squared. So order of operation, you do the exponent first. 1 squared gives me 1. 1 plus 4 is going to give me 5. So y is equal to 5. So the equation tells me if you want x to equal 1, then y is going to have to equal 5 in order for it to be a solution. So this gives me the ordered pair. Let's try that again. Trying to draw an arrow here. 1, 5. So pause the video. Why don't you guys try one? So pick a number for x, plug it into the equation, let the equation tell you what y is equal to. Find one more solution on your own. In a moment, after you unpause the video, I'll go ahead and give you a few solutions. Hopefully the solutions that I put on the screen will match one of the ones that you picked. Right. I feel like I said that wrong. So hopefully one of my solutions will match the solution that you got. All right, so you could pick 0 for x. That's always a good choice. I'll try to write that again, 0. You could pick -1 for x. You gotta be a little bit careful when you're scoring a negative number, but that's still a good choice. In fact, it's a necessary choice. If you do not choose a negative value for x in this exercise, you will not get the complete picture of the graph. So you actually do need to pick some negative numbers. You could pick 2 for x, you could pick -2 for x. I think we'll kind of stop with that. So let me do -1 here because I already have 1. So if I plugged in -1 here, -1 squared actually comes out equal to +1, right? So even if this was a -1 here, when you square it, it comes out positive. 1 plus 4 is still going to give me 5. So for x equals -1, we'll get 5 again for y. So that gives me the point -1, 5. Let's do 2. So if I plug in 2 here, I'll get 2 squared, which will be 4. 4 plus 4 is going to give me 8 for y. So I'll get 8. If you were to plug in -2 for x, -2 squared also comes out equal to +4. And so again, you'll get 4 plus 4, which will again be +8. And if you plug in 0 for x, 0 squared gives you 0. 0 plus 4 is going to give us 4 for y. All right, so this gives us 5 points to graph. So let's go ahead and plot these points. We have 0, 4, which will be this point right here. We have 1, 5, which is this point right here. Again, if you only stop at 2 points, it always looks like a straight line. So it's very dangerous to only find 2 solutions. So let's go ahead and plot this other positive one here. 2, 8 is going to be this point right here. And that's our first indication that the pattern here is not a straight line because there's a definite bend with these 3 points. So it's not just going in a straight line, it's bending upwards. So we're going to have some kind of curve here other than a line. If you only pick positive numbers for x, this one here, this one here, this one here, this is all you're going to see of the graph. And it only gives you half the picture. So we can be certain that going to the right, the graph is doing something like this. So the pattern here is fairly clear. Was it doing as it's going to the left? I don't have any information about that. I don't have any solutions over here. I'd have to guess. Or I might just leave my graph like this, but it would be wrong, right? So I don't want to guess what's happening to the left. I don't want to just leave the graph the way it looks because there's probably more going on over here. So it's really important that you choose some negative values for x whenever you're dealing with a square function like this. So if we plot this point, -1, 5, we find that what the graph actually does is bends back up the other way. So instead of heading down this way or going to, so like we could make guesses, it might do this, it might do this, it might do this. It's unclear because we didn't have any solutions graphed on the left-hand side of the Cartesian coordinate system. But by plotting that point, it becomes clear that these are not the way the graph is going to go. It's actually going to head back up. So let me undo all those guesses there. This point clearly directs me back up. And we could plot one more point just to confirm. -2, 8 gives me this point here. And so it's really clear that the graph is going to head back up after it passes this point here. And so the left half of the graph is going to look something like this. And we get a parabola. So that's the name for the shape of this graph. It's a U shape. And that's what the pattern of the graph will always be if x is getting squared. Right? If the highest power of x is to the second power, then this is the shape of the graph. All right, let's do one more example. I know this has been kind of a long video, and I'm sorry, as I mentioned earlier in the video, I haven't had dinner yet, and I'm kind of hungry, and I feel like I'm a little bit out of it. So I think that slowed me down a little bit. This one is an absolute value function. Right, so we have y equals the absolute value of x minus 6. And we're going to get a different pattern with this equation as well. So each different type of equation will give you a different pattern for your graph. We have linear equations where the pattern is a line. We have square functions where the pattern is a parabola. Let's see what the absolute value function does. What kind of shape will we get with this? All right, so we'll make a chart. I'll just go ahead and put the chart over here. Again, it's already solved for y, so the easy direction to go here is we will pick a number for x, plug it into the equation, and then let the equation tell us the value for y. So I'll start off with the same old number I always like to pick. I'll pick x equals 1, plug that into the equation for x. Right, and so we're going to get y equals the absolute value of 1 minus 6, which is -5. So the absolute value of -5, if you guys remember from chapter 1, absolute value always makes numbers positive. So the absolute value of -5 becomes +5. So we get y is equal to 5. All right, so that's one solution to the equation. We need several more in order to find this pattern. So pause the video, and I want you to find a solution to this equation before I find more. And hopefully, so in a moment, I will go ahead and find some more solutions to this equation. Hopefully, one of the solutions I find will match the solution that you found. So pick a different number for x, plug it in, get a corresponding value for y. All right, so hopefully you found another solution to this equation on your own. You might have chosen 0 for x. That's a great choice. You might have chosen -1. You might have chosen 2. You might have chosen 3. So here are some pretty common choices I would imagine students would pick. So I'm going to do one more of these over here and write it out, and then the rest of them I'll just do mentally and write the numbers up. And again, you can confirm them on your own if you want to. So let's do, I don't know, let's do -1. I'll go ahead and do that one over here. So if I plug in -1 for x, Negative 1 minus 6 will give me negative 7 here. The absolute value of negative 7 will be positive 7. So I'll get positive 7. And if you learned something from the last example, you would have seen, choosing negative numbers for x is a good idea. So when you're finding solutions to an equation, you should choose some positive numbers for x and some negative numbers for x, because you never know if the equation behaves differently when x is negative. What we're going to find here is that it doesn't actually behave differently for negative or positive values, but it does have a different behavior for another reason. And so if you plug in 0 for x, you get 0 minus 6, which is negative 6. The absolute value of negative 6 will be positive 6. If you plug in 2, you get 2 minus 6, which is negative 4. The absolute value of negative 4 is positive 4. If you plug in 3, you get 3 minus 6, which is negative 3. The absolute value of negative 3 is positive 3. And if you plot all of these points, 1, 5, 0, 6, negative 1, 7, 2, 4, 3, 3, you might be surprised to see the pattern is a straight line. And so you might say, oh, I guess that's my graph. It's a line again. But that shouldn't be the case. This absolute value should have some kind of effect on the graph to make the shape of the graph a different pattern than just a straight line, right? The only kind of equations that will give us lines as patterns for our graphs are equations that look like this, where there's no absolute value, nothing is getting squared. Then the equation, when you graph it, should come out as a line. If there's anything else going on above and beyond that, the pattern of the graph shouldn't just be a straight line. So the fact that my graph looks like a straight line means I just don't have enough information yet. And the problem that we're running into is that every number I've chosen for x has had a negative number result in the absolute value. We haven't seen any results here where I choose a number for x where I get positive numbers in the absolute value, because that's where absolute value behaves differently, right? We get different results for negative numbers in the absolute value than we do for positive numbers. So we need to explore that in the solutions that we're finding. And so I don't start getting positive numbers inside the absolute value until I start choosing numbers like 7 or 8. Right, so if I plug in 7 here for x, I get 7 minus 6, which will be positive 1. And that's going to behave differently than when I'm getting negative numbers inside my absolute value. And because of that different behavior in the absolute value, I'm going to get a different behavior in my graph. So the absolute value of 1 is just going to be positive 1. It's just going to leave that number alone. Whereas here, it didn't leave the number alone. It changed it to positive 7. Right? And so there's a different behavior there. So I need to see what that does to my graph. So if I plot 7, 1, what you're going to see is it doesn't line up on that same line. If I plug in 8 for x, I'll get 8 minus 6, which is 2. The absolute value of 2 is going to be 2. And so I'll get 8, 2. And you'll see that we start getting a line going in a different direction here. So what's going to happen is we're going to get a V shape. And where that V shape pivots is actually wherever you would get 0 inside your absolute value. So what number would I have to choose for x to make this 0 out? I would have to choose 6. So if I plug in 6 for x, I get 6 minus 6, which is 0. The absolute value of 0 is 0. And so I'll get 6, 0 here. And that's where the V shape is going to change directions. So what we're going to get on the left-hand side is a line going through all these points here. And it's going to end at 6, 0. I'm sorry, it's a little bit off the mark there. And then it's going to make a 45-degree angle here and cut back in the other direction. Right? And so we get a V shape. So for absolute value equations, it's very common, not very common, it's necessary that the graph will be a V shape. And if you know this ahead of time, that can be really helpful when you're graphing so that you know what to expect. If x is squared, you should be getting a parabola. So plot points until you find that shape. If x is inside an absolute value, you should be getting a V shape. So plot points until you find that shape. All right, so that is section 2.1 about the generic method for graphing.